Alright, so looking at page 183, number 37, piecewise defined function. Let's see, what do the directions say? Find the critical numbers. Find the intervals where it's increasing or decreasing. And then find the relative extrema. Okay, so that's like all the things you could do, but they're all related things. So it kind of walks us down the path. Critical numbers to increasing, decreasing. So that's the number line thing. And then we can use that to find relative extrema. So let's break this apart here. So when x is less than 0, f of x is 4 minus x squared. F prime of x is negative 2x. So that would be 0 at 0. Okay, I mean, I'm glad x equals 0 showed up as a critical number, because at 0 we were jumping tracks here, so something may have been funny going on. When x is greater than 0, f of x is negative 2x. So f prime is negative 2. Well, that's never equal to 0, so no critical numbers when we're greater than 0. So the only thing I'm worried about is what's happening at 0. And I was worried about that already. Let's see if this thing is even continuous at 0. So that's where I need to check from the left and from the right. So the A branch and the B branch. So I'm not doing the full continuity test where f of x exists, limit exists, and they're equal to each other. But that's kind of what I'm doing. From the left, 4 minus 0 is 4. So that's from the left. From the right, f of 0 is 0. So I've got to jump at 0. So if I've got to jump at 0, I don't have a derivative of 0. That means this thing is not continuous and therefore not differentiable at x equals 0. So x equals 0 is a critical point. Turns out not because the derivative is 0, but because there's not a derivative, because there's some sort of jump going on at 0. I think I still want to do the table of value, or the number line here. So let's test negative 1 and 1 into the derivative, although we got to be extra careful here because I got to be careful which derivative I'm testing it into. So at negative 1, I need to use negative 2x. So f prime is positive. So f is increasing. For 1, I need to use f prime equals negative 2. So that would mean f is decreasing. Oh yeah, hold on. Let's back up and make sure we're answering the questions. Find the critical numbers. Okay, so the critical number, the only one is x equals 0. Did that. Part B. Find the intervals where the function is increasing or decreasing. Okay, well, it's increasing from negative infinity to 0. It's decreasing from 0 to infinity. Here's part B. Part C, super tricky because it says apply the first derivative test to identify all the relative extrema. Well, it sure looks like there's a max at x equals 0. But there's a jump at x equals 0, so I better be real careful about what's going on at 0. I think I need to graph this thing to see what's happening. So just old school algebra 2 graphing this. Let's see, negative 2x. It doesn't have to be perfect, but so when x is less than 0, y equals negative 2x. When x is less than 0, 4 minus x squared on this side. So that would start at 4. 1, 2, 3, 4. With a closed circle because of the equal to sign. And that would just be an upside down parabola. So I would say there is a max at 0, although it doesn't have a neighbor on the right hand side, so that's a little bit tricky. But yeah, he's at the top of a mountain, so there's a relative max at 0, 4. That was a tricky one. What if it hadn't been x less than or equal to 0? What if this had just been x is less than 0 and that had been an open circle? Would there be a relative max? No, because you'd be getting closer and closer, but you'd never get there because of the open circle. So this one has a relative max, but just barely. And it still fits the first derivative test, but man, that was tricky, and we might have missed it if there'd been an open circle there. So 37, that's a tricky one because of the jump. So you got to be real careful with the jumps. So you were right to ask about 37 and 39. You have to be extra cautious at a potential jump. Just as an aside, it's possible that the jump they met and it's continuous, but it's a cusp. It's possible that it didn't really even jump at all, that it was a kind of a smooth transition and you wouldn't have to worry about it. But you have to really investigate at those jumps what's going on.